The problem statement in question 11 is as follows. Which term of the AP 3, 5, 27, 39 and so on will be 132 more than its 54th term? So we are given this AP and we know the exact parameters of the AP because we know the first term, which is 3, and we know the common difference, which is the difference between any pair of successive terms, so that's 12. And we have to find the position of that term in this AP, which is 132 more than its 54th term. Now there are two slightly different approaches to solve this problem. One of them is a more visual approach, which can solve the problem very fast, and one of them is a more algebraic approach, and I'm going to show you both ways of solving this problem. Okay, so first let's discuss a more visual approach. So look at this number line kind of representation for the arithmetic progression. So we see the first term, second term, third term, fourth term, and so on. And here's the 54th term of the AP, and we need to find out that term which is 132 more than the 54th term. And in other words, we need to find out the index of this term. So we need to find out n. Now we spoke about the common difference of this AP being equal to 12 because the difference between any pair of successive terms is 12. So D is equal to 12, and this means that to take this jump of 132 units from the 54th term, how many jumps of D of size D would we have to make? So we would have to make 132, the total gap, divided by 12, the size of each jump, and this is 11. So we would have to make 11 jumps, or we would have to go 11 terms ahead from the 54th term to land up at this term, which is 132 more than the 54th term. And this means that this term is, to find this term, to find the position of this term, all we need to do is we need to add 11 to 54. So that's 65. And this means that T65, or the 65th term of the AP, is 132 more than the 54th term. Now let's discuss a more algebraic way to solve the same problem. So the first term of the given AP is 3 and the common difference is 12. Now one algebraic approach could be to find the numerical value of the 54th term, and this will be equal to A plus 53D. And we can now substitute the values of A and D and find the 54th term, and then we can find this term, the term whose position we are trying to find. We can find this term by adding to T54 this number 132, and then from here we can back calculate the value of n. But a more elegant approach is not to evaluate the numerical value of the terms at all and directly use this expression for T54. So T54 is A plus 53D. This means that the nth term which we are trying to find, whose position we are trying to find, this is T54 plus 132. Now T54 is A plus 53D, and this 132 I'm going to write it as 11 times 12. And because 12 is the common difference in this case, D is equal to 12, so I can write 132 as 11D. And this basically means what we discussed earlier in the more visual approach, that to make this total jump of 132, we have to make 11 jumps of the size of the common difference. So we get Tn as A plus 64D. So I can write this as A plus 65 minus 1D. I'm writing this in the form A plus n minus D, n minus 1 times D. So this means that if Tn is this expression, then n is equal to this number, which is 65. So once again, we arrive at the same result, that the term which is 132 more than the 54th term is the 65th term. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.